In this problem, we have theta is equal to arctan 4 arctan negative 2 over 5, and we're being asked to find sine theta. Well, the first thing is we need to kind of define theta. So arctan 4, we're going to kind of break it down and just say that is a partial angle of alpha, and arctan negative 2 over 5 is a partial angle of theta, which we'll call beta. And we can draw triangles for alpha and beta separately. So that's what we've done here. So angle alpha, or arctan 4, I've shown as a slope of 4. So 4 over 1 is my rise over run. And then my hypotenuse works out to be root 17. And then we've done the same for arctan negative 2 over 5, which we're going to call beta. So angle beta is in quadrant 4, and it has a slope of negative 2 over 5. And using the Pythagoras, we get root 29. Now, the reason why this is particularly difficult is because now we have to find the sine of when we put those two angles together, which is very complicated. Okay, so we're going to need some help here, and our help comes through this trig identity formula. So there's a formula that allows me to add two angles together and find the sine of those, the sum of those two angles. And this is a formula that you really don't encounter till grade 12 math, but this is a formula that we use in grade 12, and it's called the sum of sines, or sum angle identity for sine. And allows us then to combine two different angles and the trig of two different angles. And without this, we really wouldn't be able to do this problem. So just to make sure we are on the same page, we've defined arctan as angle alpha, arctan of angle beta, and when we add those together, we get angle theta. So that really is the same as theta. That is the angle theta in there. And the formula that we're going to use is sine alpha cos beta plus sine beta cos alpha. And as long as we know the individual sines for alpha and beta and the individual coses for alpha and beta, we're able to just plug it into this formula and solve it. And we're not going to prove why this formula works, but this is a very useful formula in that way. So if I want to find sine of angle theta, I'm just going to apply this formula based on what I have here. So sine of theta is going to be equal to sine alpha. Sine alpha for my picture is 4 over square root 17. Cosine of beta is going to be 5 over square root 29, and plus sine beta, negative 2 over square root 29, and cos alpha is going to be 1 over square root 17. And when I put that all together, I end up with 20 minus 2 in the numerator, or 18. In the denominator, when I multiply those two together, I end up with square root of 493. And this represents the sine value of when I put those two angles together.